What is building information modeling, BIM? Have you ever thought about how the tall skyscrapers and complicated infrastructures of our towns are planned and put together with such accuracy? What if there was a new tool that not only sped up the building process, but also made it easier for architects, engineers, and contractors to work together? Join us as we explore the world of building information modeling. We'll find out how this cutting-edge method is changing the building business by saving time, money, and quality. Is BIM really going to change the way our future skylines look? Let's find out. Building information modeling is a revolutionary process that involves the creation and management of digital representations of physical and functional characteristics of places. This approach has transformed the architecture, engineering, and construction AEC industries, providing an integrated platform for planning, designing, constructing, and managing buildings and infrastructure. This video delves into the intricacies of BIM, exploring its history, key components, benefits, challenges, and future trends. BIM was developed in the 1970s, but became a standard phrase in the early 2000s. Varying countries have developed standards and adopted BIM at varying paces. In 2013, Building Semar developed industry foundation classes, data structures for representing information, into ISO 16739, and in January 2019, ISO 19650 was launched from UK BIM process standards from 2007 onward. BIM originated in the 1970s. Chuck Eastman's Building Description System and Glide, RUC APS, Sonata, Reflex, and Gable 4D series were workstation products that modeled buildings in the late 1970s and early 1980s. The early applications and hardware were expensive, limiting their adoption. Lizarin praised RUC APS, Sonata, and Reflex for their pioneering work. BIM products differed from architectural drafting tools like AutoCAD by allowing the addition of additional information to the building model. Graphisoft has been producing BIM solutions longer than its competitors. Hence, Lizarin considered ArchiCAD one of the most mature BIM solutions on the market. Graphisoft founder Gabor Boyder wrote to Jonathan Ingram in an open letter that Sonata was more advanced in 1986 than ArchiCAD at that time, and surpassed Alria. The term building model was first used in papers in the mid-1980s. In a 1985 paper by Simon Ruffle, published in 1986, and in a 1986 paper by Robert Aish, then at GMW Computers led, developer of RUC APS software, referring to its use at London's Heathrow Airport, Van Netterveen, F.P. Tolman. However, building information model and building information modeling did not become widespread until 10 years later. Autodesk released a white paper on building information modeling in 2000 and 2018, and other software vendors began to claim their involvement in the field. In 2003, Autodesk, Bentley Systems, Graphisoft, and other industry analysts contributed. Jerry Lizarin popularized and standardized the term for digital building process representation. Interoperability, BIM standards. Some BIM software developers use proprietary data structures. Therefore, data and files from one vendor may not work with another. Neutral, non-proprietary, or open protocols for transferring BIM data between software applications enable interoperability. Poor software interoperability has long hindered industry efficiency and BIM adoption. In August 2004, the U.S. National Institute of Standards and Technology conservatively estimated that the U.S. capital facilities industry lost $15.8 billion annually due to the highly fragmented nature of the industry. The industry's continued paper-based business practices, a lack of standardization, and inconsistent technology adoption among stakeholders. CIB Steel Integration Standard, CIS/2, a product model and data interchange file format for structural steel project information, was an early BIM standard. CIS/2 allows integrated information exchange throughout steel frame structure design and construction. In the late 1990s, the University of Leeds and the UK's Steel Construction Institute created it with Georgia Tech's input. The American Institute of Steel Construction adopted it as its structural steel data exchange standard in 2000. Building Smart's industry foundation classes and AXML data structures are typically associated with BIM. ISO 16739, an international standard, recognizes IFC since 2013. Construction operations QOBI is linked to BIM. In 2007, Bill East of the U.S. Army Corps of Engineers created COB to maintain equipment listings, product data sheets, warranties, spare parts lists, and preventative maintenance schedules. This information supports operations, maintenance, and asset management once a built asset is in service. In December 2011, the U.S.-based National Institute of Building Sciences approved it as part of its National Building Information Model Standard. 27. COB can be used in spreadsheets, IFC, and FXXNL software. Building Smart developed COB Lite, a lightweight XML format, in early 2013 and released it for evaluation in April 2013. British Standard BS 1192-4 was issued in September 2014. ISO issued the first two parts of ISO 19650, a framework for building information modeling based on UK process standards, in January 2019. New ISO 19650 portions on asset management and security management are based on UKBS and PAS 1192 regulations, known as RDSCW, IEC/ISO 81000. 346-12-2018 is a reference designation system for construction works. RDSCW allows BIM integration with complementing worldwide standards-based classification systems for power plants. A shared digital representation of a built asset eases design, construction, and operation and informs decisions. BIM is a digital representation of a building's physical and functional qualities. A BIM is a common knowledge repository for facility information from conception to demolition, providing a trustworthy basis for choices. Traditional building design relied on two-dimensional technical drawings, plans, elevations, sections. Building information modeling adds time 4D BIM, cost 5D BIM, asset management, sustainability, and more to width, height, and depth. Thus, BIM goes beyond geometry. It covers spatial relationships, geospatial information, quantities and properties of building components, such as manufacturer's details, and enables a wide range of collaborative processes related to the built asset from planning to construction and operation. BIM authoring systems show designs as collections of objects vague and indeterminate, general or product-specific, solid shapes, or void space-orientated, like a room with geometry, relations, and characteristics. Building model views can be extracted for drawing generation and other usage using BIM applications. BIM software parametrically defines objects as parameters and relations to other objects. So if a related object is changed, dependent ones will automatically change. Each model element can carry attributes for selecting and ordering them automatically, providing cost estimates and material tracking. The design team architects, landscape architects, surveyors, civil, structural and building services engineers, principal contractor and subcontractors, and owner/operator can exchange a virtual information model using BIM. Each professional adds discipline-specific data to the shared model, often a federated model that combines several disciplines. Models 38. Combining models allows visualization of all models in a single environment, better design coordination and development, clash avoidance and detection, and time and cost decision-making. Project lifecycle use. BIM is used throughout the entire lifecycle, not only planning and design, cost management, construction management, project management, facility operation, and green building assist building lifecycle management. Building information model management. BIMs cover the concept to occupation period. To efficiently manage information processes during this duration, a BIM manager may be hired. Since BIM's level of detail depends on its use, companies are considering developing BIMs in various levels of detail. From the pre-design phase onward, the BIM manager develops and tracks the object-oriented BIM against predicted and measured performance objectives, supporting multidisciplinary building information models that drive analysis, schedules, takeoff, and logistics. Construction management BIM. Building project participants must produce successful projects despite short budgets, limited staffing, expedited schedules, and contradicting information. Important disciplines like architectural, structural, and MEP designs must be coordinated because they can't happen simultaneously. BIM can also help detect collisions by pinpointing discrepancies. BIM virtualizes a facility before its physical construction to minimize uncertainty, improve safety, solve problems, and model and assess potential impacts. Before construction, subcontractors from every trade can input important information into the model and prefabricate or preassemble some systems. Site waste can be reduced in products delivered just in time instead of stockpiled. Material quantities and attributes are simply retrieved. Specific job scopes can be defined. Systems, assemblies, and sequences can be scaled relative to the facility or group. Using conflict or clash detection, BIM shows the team where building components like the structural frame and building services pipes or ducts may overlap, preventing errors. Facility operations and asset management BIM. BIM allows each group to add to and reference back to all information they gain, while contributing to the BIM model, preventing information loss when transferring a project from design to construction to building owner/operator. The facility owner or operator can benefit from an effective handover of information from design and construction, including via IFC or COB. ISO 19650 Part 3 covers BIM-related activities for longer-term asset management. A building owner may discover a water leak. Instead of inspecting the structure, the owner may use the model to find a water valve in the problematic area. Depending on processing power, the owner could include valve size, manufacturer, part number, and any other previously researched information in the model. The vulnerability representation of facility contents and threats developed by Leet and McKinsey to help identify building emergency vulnerabilities addressed such issues. Working BIM 2D floor layout on smartphone. BIM and facility operation can be related to Internet of Things approaches because it can incorporate dynamic information about the building, such as sensor measurements and control signals from building systems, into software to support analysis of building operation and maintenance. Mobile devices and machine-readable RFID tags or barcodes can also help access data quickly. There have been attempts to create information models for older institutions. Reference key metrics like the FCI, use 3D laser scanning surveys and photogrammetry separately or in combination, or digitize traditional building surveying methodologies by using mobile technology to capture accurate measurements and operation-related asset data for a model. Building a model during design is simpler than retroactively modeling a 1927 building, which requires many assumptions about design standards, building codes, construction procedures, materials, etc. Understanding how BIM can support a holistic understanding and implementation of building management practices and cost of ownership principles that support the full product lifecycle of a building is a challenge to proper maintenance and management of existing facilities. APA 1000 Total Cost of Ownership for Facilities Asset Management, an American national standard, uses BIM to factor in a variety of critical requirements and costs over the life of the building, including energy, utility, and safety system replacements, building exterior and interior maintenance and material replacements, design and functionality updates, and recapitalization costs. Subscribe now and stay ahead in the game of innovation.